Let's use the Pythagorean Theorem to find the missing sides of a couple right triangles. Recall the Pythagorean Theorem is a squared plus b squared is equal to c squared, where c is going to be our hypotenuse. First thing that you want to do is identify your side. So remember, hypotenuse is not the slanty side. So hypotenuse is the side that's across from the right angle or the longest side. So that's my side C. Your other two sides, the sides that make up the right angle, those are going to be the two legs. It doesn't matter which one's A and B, so I'm just going to label them A and B like that. So once I have those established, I'm going to go ahead and just start using Pythagorean Theorem. So 8 squared plus 6 squared is equal to c squared, or x squared if that makes more sense to you. Let's go ahead and just do some simplifying and see what happens. So 36 and 64. Add those values together and I get 100 is equal to c squared. Now you're not done at this point. We have not found c. We found what c squared is equal to. To get rid of c squared, we're going to need to do a square root on both sides. So let's take the square root of both sides. The square root of c squared is just c, and the square root of 100, hopefully that number jumps out at you and you recognize as a perfect square. The square root of 100 is just 10, so that missing side, the hypotenuse in this case, should be just 10. If I go back and check my directions, notice they asked me to find an exact value, which we did. C is exactly 10. They also ask for an approximate answer. Well, that's not going to apply in this case because we didn't have to round it. We know it's just going to be 10 exactly. So let's see what happens on this next problem, though, where we will have to give two separate answers. Again, first thing first, identify your sides. C is not the slanted side. C is your hypotenuse, the side across from the right angle. So 6 is C in this case. The other two sides are your two legs, A and B, and it doesn't matter which one's which. Now be careful when you set these up. When some people do these, they just get in the habit of always squaring and adding the two numbers together. So they set up 3 squared plus 6 squared is equal to x squared, and hopefully you recognize right away that that's really, really wrong. C is your hypotenuse, and that has to be on its own side of the equation when you set that up. So what we should do is square and add the two legs together, x squared plus 3 squared, and that should be equal to 6 squared. So if I go ahead and continue my work on this, I've got x squared plus 9 is equal to 36. I'll need to subtract 9 in this case from both sides to continue solving this. So x squared would be equal to 27. And again, we don't have x by itself yet. I need to take the square root of both sides to find out my missing side. So I get x equals, and now at this point we have to make our decision. If they want an exact value, which they do in this case, we need to do a factor tree because 27 is not a perfect square. So 27 can be factored into 9 times 3. And then 9 can be factored into 3 times 3. We're looking for pairs of numbers, so we have a pair of 3's right there. Don't circle all 3 3's. That pair of 3's gets to go out. This single 3 that's left over is stuck inside. So my exact answer for this problem is 3 times the square root of 3. If you recall in the directions, though, they wanted two values. They also wanted the approximate answer. So the approximate one's easy to do as long as you have a calculator. So go ahead and take out your calculators, type in the square root of 27. That should come up to be about, if we round to 2 decimal places, 5.20. So there's my approximate answer, which I'll label, approximately. And then my exact answer was 3 times the square root of 3.